Hello students, in the previous session what we have done was we have discussed theoretically the meaning of uniformly accelerated motion and non-uniformly accelerated motion, and then we have discussed the concept of acceleration as well. We have discussed the various cases when final velocity is equal to the initial velocity, right? Then when final velocity is greater than that of the initial velocity, and when final velocity is less than that of the initial velocity. So let us recapitulate the topics which we have discussed in the earlier session. Now, if a body covers unequal displacements in equal intervals of time, then the body is said to possess non-uniform motion. So students, for a body to possess non-uniform motion, the velocity of the body must change. It can change either at a constant rate or the velocity of a body can change at a variable rate. In case the velocity of the body changes at a constant rate, then it must be the case of uniformly accelerated motion. And in case of random change in the velocity of a body, then it is the case of non-uniformly accelerated motion. So students, acceleration means the time rate change in the velocity of the body. That is, the change in the velocity with each unit of time. And if I say acceleration is constant, what does it signify? It signifies that the velocity of the body is changing, mark my words, the velocity of the body is changing at a constant rate. So per unit time, the change in the velocity would be same. And change means either it can increase or it can decrease. A, if it is having positive value, it is the case of acceleration. The body will speed up. If A is having negative value, it means that the body will slow down. And A negative, it means that it is the case of deceleration, or it is also known as retardation. Right? So, what we'll do is, we will bifurcate uniformly accelerated motion into two categories. This is uniformly accelerated motion when the value of A is positive, and this is the case when the uniformly accelerated motion, the same case when A is having negative value. So it is the case of acceleration, it is the case of retardation. But mind it, in both the cases the value of A is constant. The value of A is constant. So that is why it is the case of uniformly accelerated motion. Right? In this case, when A is having constant positive value, it is suggestive of the fact that the body under consideration increases its velocity at a constant rate. And in this case, when A is having constant negative value, it signifies that the body under consideration has velocity which is decreasing at a constant rate. Clear? So now let's discuss the position time graph and the velocity time graph in both the cases. Now look, we have discussed the significance of position time graph as well, right? The slope of the position time graph that gives us velocity, isn't it? While the slope of velocity time graph, that will give us acceleration, right? We'll come to this topic, but before that we need to discuss the nature of the graph that we should obtain. So in the case of uniformly accelerated motion, when A is having constant positive value, then the nature of the graph should be parabolic. It should be like this. It should be like this. I'll explain this. Let us divide this time into three equal intervals of time. These are the three equal gaps I have considered. These are three equal gaps. Equal gaps. This is T, this is 2T, and this can be considered with 3T. Right? And then draw perpendicular from these lines. Right? These are the perpendiculars. These are the three equal intervals of time. Okay. Okay, now concentrate on this. Please concentrate on this graph. During this time interval, these are the three equal intervals of time. During this time, body has covered this much distance. Right? Body has covered. This is suppose the origin. Body has covered distance from O to A during this time, during time T. During the next interval of time, equal interval of time, the body has covered distance from A to B. And during the next equal interval time, the body has covered distance from B to C. Students, please try to interpret this particular graph. We are taking equal intervals of time, but the body is covering unequal displacements in equal intervals of time. That is when the body is said to be in non-uniform motion. And in this case, look, with each interval of time, the body is covering more and more distance. And that is possible only if the speed of the body is increasing, the velocity of the body is increasing. Then only it will cover more and more distances per unit time. And if the velocity increases, then A is positive, that is acceleration is positive. So this is the case. When acceleration is having positive value, constant positive value, then the graph would be a curve and it will be like this. So it clearly suggests that per unit time, the increase in the displacement increases. Again I will explain. During the first time period, small t, the body is covered distance from O to A, the small one. In the next equal interval of time, the body has covered distance from A to B, much larger than the previous one. During the third equal interval of time, the body has covered distance BC. It is much larger. So what do you conclude? With the passage of time, with the passage of equal intervals of time, the body tends to cover more and more displacements per unit time. And that is possible only when the velocity of the body is increasing, and then A will have positive value. Acceleration is positive only when final velocity of the body is greater than that of its initial velocity. So that's the graph, position time graph of a body having uniformly accelerated motion when A is positive. When A is positive, right? Now let's discuss this case. A is constant but having negative value. So it will be like this. Now let's try to understand. Again, let's divide into 3 equal parts. Let us divide into 3 equal parts. This is the origin. So let's drop the perpendicular. Let's show it with the help of dotted lines. These are the dotted lines over here I am drawing. Okay. This is suppose A. This is suppose B. And let us consider this to be C. Let us consider this to be C. Now look students, again let's try to interpret this graph. Let us try to interpret this graph. What to do is, let's consider this interval of time. Let us consider this interval of time. During this interval of time, the body has covered displacement equal to OA. It's quite big. It's quite large displacement covered by the body during the first interval of time. Let's consider the second equal interval of time. During the second interval of time, the body has covered much shorter, much lesser displacement. Let's consider the third interval of time, equal interval time. In this case, the body has covered still lesser displacement. So what do you conclude? With the passage of time, the body is covering lesser and lesser displacement. So this is feasible, this is possible only when the velocity of the body is decreasing. And when the velocity of the body decreases, it must be the case of retardation or deceleration. That is when the value of A is negative. I hope you have understood completely. This is the case when A is having constant positive value, and this is the position time graph of the case when A is having constant negative value. One more thing student. As I stated, the slope of, this is a very important point, slope of position time graph, slope of position time graph will give velocity of the body. This is a very important point. What I mean to say is that slope, and that is given when it is curved. At a point, the slope is given by drawing a tangent at that particular point. Suppose you wish to find the slope at this point. So you draw a tangent over here, like this. This is a tangent. If you wish to find slope at this point, so you draw a tangent like this. This is the tangent. Now if you wish to draw a tangent at this particular point, then it will be like this. At which point, suppose this is x, this is y, and this is z. At which point the slope is maximum? I am talking about this. At this point, the slope is this. This is the tangent which gives the slope. This is the tangent. Slope. So, which is maximum at point z? Here the slope is maximum. The angle which it makes with the horizontal. That tangent theta, tan theta, that will give you the slope. So, more the angle which the tangent subtends with the horizontal, more is the slope. Right? So, this is quite flat, this is steeper, and this is still steeper. So, here the slope is maximum. So, at point z, the slope is maximum. And slope of position time graph gives us velocity. Therefore, the velocity of the body is maximum at point z. The velocity of the body is minimum at point x, because here the slope is minimum. So, please do remember this point. Slope of position time graph will give velocity of the body. So, here slope will give us position. It is x2 minus x1 divided by this. So, slope will give us velocity. Right? And slope, in the subsequent class you will study, slope is given by tan theta. Theta is the angle which this slope or which the tangent at a point makes with the horizontal. That is theta. And tangent theta. So, theta greater means tan theta greater. Tan theta is greater means the slope of the line is greater. So, obviously here it is the horizontal. This angle is much greater as compared to this angle or this angle. Right? So, one thing can be easily concluded. Here with the passage of time, the speed increases, the slope increases, means the velocity of the body also increases. Right? So, the velocity of the body increases when A is having positive value. Over here, at this point, this is suppose x, this is y, this is z. So, suppose at point x, I need to find out the velocity of the body. So, what I do? I draw a tangent at this particular point. This will give the slope. This is the slope. At this point, this is the slope. And at this point, this is the slope. So, look. Here, the slope is quite large. That is, it is quite steeper. Here, it is becoming flatter and flatter. So, here at point x, the slope is maximum. While at point z, it becomes flat. So, the slope almost approaches to 0. What I mean to say is that, here at point x, velocity is greater. Point y, it is smaller, and at point z, it is minimum. So, here, velocity at point x is greater than the velocity at point y, than the velocity at point z. Here, it was a different case. Here, Vx is less than Vy is less than Vz. Concentrate on the slope, students. Slope of position time graph that gives the velocity, and the slope at a point is given by drawing a tangent at that particular point. That is what I have done over here. Here, the slope keeps on decreasing. Here, the slope keeps on increasing. So, here, the graph becomes flatter and flatter. So, the slope decreases, means velocity is decreasing with the passage of time. And velocity of the body decreases only when it is the case of retardation. That is when the value of A is negative. I hope you have understood this topic, right? Position time graph. So, the significance of the position time graph is that the slope of position time graph always gives us velocity. If the slope is increasing, it means that velocity is increasing. If the slope is decreasing, it means that velocity is decreasing. Right? Let's consider this. A should have constant value. So, constant means it should be a straight line. PT graph must be a straight line, not parallel to time axis. In case it is parallel to time axis, then what happens? Velocity will remain constant. So, it shouldn't be parallel to time axis. It should be a straight line, but not parallel to time axis, right? So, it should be like this. It should be a straight line. This is t equals to 0. At t equals to 0, that is initially, whatever is the velocity possessed by the body, that is known as its initial velocity. U stands for the initial velocity. So, at this point, point A, the body is possessing initial velocity u. Now, with the passage of time, as the time elapses, this velocity of the body keeps on increasing at a constant rate. It increases at a constant rate. Students, I have already told you that straight line, it means that slope is constant. Let's see what is the significance of the slope of this graph. The coordinates over here would be 0, u. And suppose over here time t has elapsed and the final velocity is v. Suppose this is final velocity v. So what will be its coordinate? T and v. This can be considered to be x1, y1. This can be considered to be x2, y2. Now let us see slope of Vt graph. Slope of velocity time graph. Let's see what will be its significance. As I told you, it is y2 minus y1 divided by x2 minus x1. That's slope, tan theta. And it is given by y2 minus y1, that is v minus u, divided by x2 minus x1, that is t minus u. That is slope gives v minus u by t. And in the previous discussion, in the previous lecture, we have discussed this time rate change in the velocity of the body is known as acceleration. So slope will give us acceleration of the body. This is the key point. The slope of Vt graph will give the acceleration of the body. Now here the slope is constant. You can find the slope between any two given points on a straight line. It will come to be constant. So slope constant means at any point you can draw a tangent, it will be the same slope. So slope constant means acceleration is constant. Acceleration is constant. Clear? So in case the body is having uniformly accelerated motion, then Vt graph is a straight line. And in case A is positive, it should be have positive slope. This is uphill, positive slope. Downhill, that is negative slope. Positive slope means A is having positive value. A having positive value means the velocity of the body is increasing at a constant rate. Look, with the passage of time, the velocity of the body will keep on increasing. It will keep on increasing. Coming to this, here again A is constant. But students, A is having negative value. It means that slope of Vt graph will give us acceleration. So here slope should be negative. Slope negative means downhill. Slope positive means uphill. So here again it will be a straight line. It will be a straight line, but it will have negative slope. That is downhill, negative slope. So over here you can check. With the passage of time, the velocity of the body is decreasing. With the passage of time, the velocity of the body is decreasing. So here final velocity of the body must be less than that of its initial velocity. Initially the body possesses this velocity. Finally the body possesses this velocity, this one. So final velocity is less than initial velocity. It is then A is negative. And straight line suggests that A is constant. So that it is the case of uniformly accelerated motion. So students, velocity time graph would be a straight line, either having positive slope or having negative slope, depending upon whether the value of A is positive or the value of A is negative. So what is the significance of Vt graph? The slope of Vt graph will give the acceleration of the body. What else? The area under Vt graph. Look, suppose this is the time interval during which the distance or displacement covered by the body is to be found. Then what do we do? We tend to find out the area under Vt graph. So the area under Vt graph, that will give us the distance covered by the body between the two given intervals of time. This also we have done previously as well, right? So here, if we intend to find out the distance covered by the body between this time interval, so what do we do? We will drop perpendiculars, and this area of the shaded portion will give the distance or displacement covered by the body between this interval of time. So again I repeat, what is the significance of position time graph? The slope of position time graph will give us velocity. What is the significance of velocity time graph? The slope of velocity time graph gives us acceleration, while on the other hand the area under velocity time graph gives the displacement covered by the body between the two given intervals of time. One more case. Suppose VT graph is like this. This is the VT graph given. You must remember, VT graph, if it is a straight line and parallel to time axis, that will represent uniform motion. Students, what will be slope over here? The line is flat. What is the angle which this line is making with the horizontal? It is making 0. So theta is 0. So tan theta is 0. So therefore slope is 0. And slope of VT graph is acceleration. So acceleration is 0. So students, in the case of uniform motion, which we have already discussed earlier, the velocity is constant. And we have discussed just now. If the velocity is constant, then acceleration is 0. So in the case of uniform motion, VT graph is a straight line parallel to the time axis. So why we have discussed this graph again is to show you that if the line is flat, if the line is parallel to the horizontal axis, it means that slope is 0. So here acceleration is 0. It is the case of uniform motion. It is the case of uniform motion. So students, I hope you will learn more about these graphs. You will watch this video again and again to understand the finer aspects of this thing, and be very clear in your mind regarding uniform motion, non-uniform motion, acceleration, accelerated motion, uniformly accelerated motion, uniformly retarded motion, non-uniformly accelerated motion, right? All these terms should be crystal clear. The significance of various graphs, the nature of the graphs obtained between position time and velocity time in each and every case, right? So I hope you will study very well. In the next session, we'll discuss some numericals based on this, and we'll further deal with this particular topic, right? Till then, do take very good care of yourself, right?